Let me tell you just a little bit about the history of operating systems. Back in the mid-20th century, there was a lot of excitement over the design of digital computers. There were a lot of important names in the early history, people like John von Neumann, Conrad Zuse, Presper Eckert, Mauchly, Maurice Wilkes. I really encourage you to go look up their names if you're not familiar with them. They're fascinating and important people in the history of computing. The term von Neumann computer architecture is generally used to refer to is generally used to refer to a computer that can store a program as a form of data, rather than in the wiring of the computer itself, but it's generally acknowledged that all of those people above sort of contributed to the basic ideas. In fact, von Neumann himself was reportedly embarrassed by the use of the term von Neumann architecture because he wrote the report on the UNIVAC architecture, but the architecture itself was actually designed by a group of people. So he always intended for it to be all of their names on the report, and instead it wound up with just his name on the report, and so it got referred to as the von Neumann architecture. So all of those were using discrete components, including vacuum tubes and the like. But by the early 1950s, there were transistors, and then shortly thereafter, small-scale integrated circuits that allowed you to have more complex logic and then larger and more complex systems. At first, each program running on the computer system actually controlled the entire system. It controlled all of the I/O devices, it controlled the tape that your data was stored on, it controlled the memory, it controlled any sort of other devices, including the printer that printed out information for you. In those days, you didn't have a video screen for these things. And that led to a lot of redundant work. You had to create essentially an operating system every time you write a program. Well, eventually people decided that having an operating system as a basic piece of software that took care of loading programs and loading data from storage media, rather than recreating that infrastructure with every single program that was written, it was better to have an operating system that took care of those functions for you. So then you had an operating system whose responsibility was to load the program from some sort of storage media and then execute the program. Now still, those initial programs and those initial operating systems could only store one program at a time. Sorry, they could only run one program at a time. They loaded the program from storage, and then they ran it, and then when they were done, that program was discarded, and then it was time to load another one. Those are what were called batch operating systems. They operated serially on a set of jobs, and only one job was using the computer at a time. You had sort of a high priesthood of operators of the systems who came and took care of the machines, and they would take your job for you, and then they would run it on the machine, and then it would create some sort of output, and they would come and give you that output back. That might take overnight, it might take even a couple of days if the machine was busy. It was not an interactive system. Those original programs were stored on paper tape or on punched cards. They were decks of cards for the computer. You wrote you had your program, which was one deck of cards, and your input data, which was another deck of cards, and then you got back those two decks plus a third deck that was the output data from your run. Well, somewhere around 1956, the first actual hard drive was introduced by IBM, and that held all of 5 megabytes worth of data. And at around the same time, the initial high-level programming languages were being created, one of which was Fortran. So we had storage media, and we had programming languages, and we had the rudiments of a batch-based operating system. That's what the conditions were through, say, the 1950s. Then, in 1964, IBM introduced the System 360. It's one of the most important events in the history of computing for two main reasons. One, the software became portable, and two, they introduced multiprogramming. So The software being portable was a big deal because now all of a sudden you could write a program on one machine and then give that program to somebody else and they could run it on their machine. Prior to that point, a program was unique to the machine you ran it on. Every machine was different, and the program had to be designed and compiled for each individual machine. I don't mean just same type of machine. I mean literally every single machine was different, and so the programs that ran on them also had to be different. Well, in the very early 1960s, right around 1960, it was realized that it was possible for more than one person to use the computer at the same time. That is, you could have a terminal that connected to the computer, and that terminal could allow you to type commands to it and give you feedback. But if you did that with a person sitting in front of the computer, they essentially monopolized the computer. So only one person could be using the computer at a time. But the computer actually spent a lot of time waiting for people to type. Now, if you can find a way to have the computer do useful work while it's waiting on a person to type some input, then you can increase the number of jobs that you can finish in a day. Well, this is called multiprogramming, and the idea came from John McCarthy and was implemented first by Fernando Corbato. Both of them at MIT, both of them Caltech graduates. And I'm a Caltech graduate, so of course I'm proud of both of them. Both of them went on to win Turing Awards for their work in computing. That initial system that they created was called the Compatible Time Sharing System, or CTSS. That led on to the development of a system called Multics, which is one of the most influential systems in the history of operating systems. And from there, IBM developed their programming systems, and a group of other companies came around, including one called DEC, Digital Equipment Corporation. DEC created a series of operating systems, 10X, Top 10, Tops 10, Tops 20, and then ultimately VMS. The creators of VMS eventually left digital when the company was dying and went to Microsoft, where they created an operating system called NT, which was ultimately the basis for Windows for quite a number of years. It was the first real protected memory multitasking operating system from Microsoft intended for use on PCs. So in the 1970s, that was the setup for mainframes. There were multiple terminals and multiple users for large-scale mainframes, but also personal computers began to appear in the late 70s or in the early 1980s. They sort of recapitulated that entire history. They went from something that you had to program every single operation inside the machine, and you controlled the complete system, to essentially a batch-like system, except that you were sitting in front of the computer. But it only ran one program at a time. There was no way to have it run multiple things. Of course, there was no Windows system. There was just a keyboard and a simple monitor, usually not capable even of very much in the way of graphics, just text input and output. But it gave you something. Then those operating systems began to move on toward the more modern notion of having a kernel and having libraries. So you have the kernel, which is the core part of your operating system, the libraries that provide some basic functionality, and then individual processes. And an individual process is an instance of a program that's currently running on your computer. Now you can have multiple processes. That means you can have multiple things going on at the same time.